Hi, welcome you all to another video of Pasindu series. Today we will be discussing about projectile motion. First, let's see what a projectile motion is. If an object travels in a parabolic path, it's called a projectile motion. Now, from here to here, object has traveled in a parabolic path, right? And if we consider this motion, the motion starts from here and the object travels all the way from here to here, right? And if I split this motion into two directions, along the vertical direction, we have a motion from O to A, and it is coming back from A to O. And if we consider the horizontal direction, there is a horizontal linear motion from O to B. So therefore, first idea is a projectile motion is a motion which consists of two linear motions. One linear motion is vertical linear motion, and the other linear motion is a horizontal linear motion. Since projectile motion is an inclined motion, we will need dissolved components when solving projectile motion. So now let's recall what dissolved components are. If we have inclined vectors as f here, right, and if we know the angle between the vector and a direction, we can always dissolve a vector. Dissolving means we can always split a vector in two directions, right, in two perpendicular directions. One is towards the angle, that is cos component f cos theta, away from the angle, sine component f sine theta. Now let's see how an example projectile motion question can be solved, and let's recall everything about projectile motion. Now you can see this example question on the screen. It says, let's consider a particle projected with an initial velocity u and angle to horizontal theta. Right? Initial velocity u, angle with horizontal theta. When we solve a projectile motion, since it consists of two linear motions, being one vertical and one horizontal, we are considering these linear motions respectively and solving the question. First question is, what's the maximum height reached by the particle? Maximum height reached by the particle is this. Let's say h. To get the maximum height reached by the particle, let's use a linear motion equation vertically. From A to B, upwards, v squared equals u squared plus 2as. V squared at this point is 0. That is the maximum point. 0. U is u sine theta. So this is u squared sine squared theta plus 2. G is minus g h. Right? If we have vectors which are in the opposite direction of consideration, they are considered as minus vectors. In linear motion one also, I recalled you about basic vector rules. So this is 2gh equals u squared sine squared theta, h equals u squared sine squared theta over 2g. Question 2. What's the time taken by the particle to reach maximum point? Time taken to reach maximum point. Then again, let's use an equation from A to B. From A to B upwards, what we can do is V equals u plus AD. V is 0. U is u sine theta minus gt. So gt equals u sine theta. T equals u sine theta over g. And part 3, determine the total flying time of the particle. If we need to get the total flying time is from A to C. So let's use an equation from A to C. Part 3, from A to C upwards, S equals UD plus half AD squared. S from A to C is 0. No vertical displacement, that is 0. So 0 equals U sine theta T minus half GT squared. Take it to the other side and simplify. Half GT squared equals U sine theta T. 1 T to T cancels. The total flying time comes as 2u sine theta over g. So this time means exactly 2 times of the time taken to reach the maximum point. So if the projectile motion is symmetric, this condition is always satisfied. What is the horizontal range of above particle? If you need horizontal range from A to C, use a linear motion equation horizontally. So let's use from A to C horizontally, S equals UT. S is R. This is the horizontal range. R equals U cos theta T. Total time is 2U sine theta over G. Right? Simplify this. R will be 2u squared sine theta cos theta over g. Next one, determine horizontal velocities at points B and C. Let's mark it as VB and VC. Now we can use a linear motion equation horizontally to get VB and VC from A to B. Horizontally, V equals U plus AT. V is VB. U is U cos theta. U is U cos theta. Since this direction is perpendicular to direction of acceleration, it is neglected. So that is 0. So VB equals U cos theta. Similarly, if I need to get the velocity at C, use the equation again to C. VC equals U cos theta plus 0 again. So VC equals U cos theta. So the learning you have to get from here is horizontal velocity component of a projectile motion remains unchanged. Then we need determine the direction and magnitude of velocity at C. Right. Now, since horizontal velocity component is known, now I'm going to determine the vertical velocity component at C. So let's say that as Y. From B to C, we can use an equation like this. So from B to C, downwards, V equals U plus AT. V is Y, U is 0, plus GT. Since C is known, plug the value U sin theta over G. It cancels, and Y is U sin theta. Okay, now horizontal velocity component and vertical velocity component at C is known, right? And from this answer also, keep in mind that if the projectile motion is symmetric, the initial velocity and final velocities are going to be equal. If we consider components also, they are going to be equal. Now the resultant velocity here is in between. So let's say R dash. Resultant velocity is in between. Resultant of two perpendicular vectors can be written as resultant of two perpendicular vectors can be written as root x squared plus y squared. So this can be written as root x squared is VC squared. VC was determined as U cos theta. So VC is U cos theta. U cos theta squared plus Y is U sin theta. U sin theta squared. Simplify this. Simplify this. U squared can be taken out, and inside there is sin squared theta plus cos squared theta. This is 1. Therefore, R dash equals U, which means the projectile motion returns back to ground with the initial velocity it is projected. About the direction, if you need to get the direction of two perpendicular vectors, we can easily get it using tan theta. So let's label this as alpha. Then tan alpha can be written as y over Vc. Plug these values. Tan alpha equals y U sin theta over Vc is U cos theta. These two cancels. Tan alpha equals tan theta. Alpha equals theta. The learning there is a symmetric projectile motion returns back to ground with the same angle of projection. So I hope I gave you a quick recall about projectile motion. So study hard and work hard. Let's meet with another video of rapid recall series. Goodbye.